Okay, hi, good morning. My name is Aman Barod and my Hansen ID is H1 triple 04343. So my today's topic is Android completion process in Java. So there are many stages in this, like when you compile a Java code into an Android app, it goes through a number of stages, like from source code to bytecode, then ProGuard tool, and etc. etc. I'm here to discuss you with all these stages. So first discuss from source code to bytecode. So you will need the JDK Java Developer Kit to compile the Java code of your application, as we are familiar with that, and our code and pre-compiled classes from runtime and custom. Our code and pre-compiled classes from runtime and custom libraries are compiled first by Java, see like JIT compiler, standard Java compiler, you can say like that also. So the what happens here, the Java outputs a set of Java bytecode files. So far it looks like an Java compiler process, but the next completion step makes the make the completion process unique and some kind of like unique to the Android, like so. So it's completed. Okay, the second step is the ProGuard tool. So this step is optional, like you can omit this step if you want to. The ProGuard tool takes the Java bytecode file, like output as a step number one, and send them through a tool named ProGuard. It will minimize and obfuscate, like obstacle. Let me explain what is obstacles. To makes obscure, unclear, or unintelligible that your code. Sorry. So okay, so it is disabled by default in new Android project, but when ProGuard is turned on, and it will analyze your code into demo implementation of methods, for example, that aren't called, right? So this can dramatically shrink your distributable app package and everything. It also like obfuscates your code by changing method names and so on, making it harder to decompile package Java code by a third person or organization. Okay. So regarding of the use of ProGuard, you once again end up with dot class files. So like just minimize the bytecode. So okay, so the third step is like from minimize bytecode to the DX code. So the next step is take the output files that is optimized for Android and which can be executed by the older Dalvik runtime or the newer ART runtime, right? So okay, now we will discuss about the execution of machine of code. So the device's runtime read these dex files, output of step number 3, we can say like that. So and recompile some of the file to machine code for the fastest possible execution. Okay, so on Dalvik, this step happens as the app runs using just in time or JIT architecture also. So on the newest ART, the recompilation or translation of to machine code happens when the app is first installed, meaning that the app can run faster, and when the user runs it on his or her devices, like so. And that's how your Java code turns into something that runs on Android, like so. Eventually it starts with Java, and after a couple of steps it is transferred into something with the Android runtime can read and execute. So this was the completion process. Thank you.